Problem number 9 is asking us to find a power series representation centered at 0 of the given function, and it gives us negative 2x squared over 1 plus x squared quantity squared. So when I see a problem like this, what we're trying to do is, again, we're trying to find a power series representation. So I want to find some part of this function that I can find a power series for, and then build off of that, whether I have to add, subtract, multiply, divide, differentiate, or integrate. So when I look at this, I ignore the negative 2x squared on top because we can always multiply any kind of x term back in once we figure out the power series. So if I'm really looking at 1 over 1 plus x squared quantity squared initially, I need to figure out a way to try to get a power series out of this. Well, if this squared wasn't here, that would be perfect. But I know that if this squared wasn't here, I could be able to find a power series for it. So I'm going to start with something like that, and I'm going to see if I can get a power series out of that. So my first initial function will be 1 over 1 plus x squared. Now, focusing on this, I can find a power series representation for this because it's 1 over 1 plus x squared. All I need to do with this plus is turn it into minus minus. So I'm going to go ahead, and I'm going to do that. So I write this as minus, and that becomes negative x squared. Now it's in the perfect form that we need to use our 1 over 1 minus x formula. So this becomes n equals 0 to infinity of negative x squared to the n. And that's equal to n equals 0 to infinity, negative 1 to the n, x to the 2n. Cool, so that's a good starting place. But now we need to start working with this function to try to recreate this term over here. Well, what I'm going to do next is, again, we initially started with 1 over 1 plus x squared. And the term I just erased was the same exact thing, just split into a minus minus. So 1 over 1 plus x squared should have this same power series over here. So the next thing I'm going to do is, if I want a squared down here, well, if I have a first power down here and I want a square, I need to differentiate that power series. Again, if this was like natural log or something, I would want to integrate to get to there from here. But because the power is increasing on the bottom, differentiation is the right step. So I'm going to go ahead and I'm going to differentiate this. So I'll do it off to the side here. I have 1 plus x squared to the negative 1, if I bring this up as a negative 1 power. Negative 1 plus x squared to the negative 2 times 2x is the differential I get. So the differential of this, if I take its derivative, that gives me negative 2x divided by 1 plus x squared quantity squared. And I know that if I differentiate this left-hand side here, and I get this, I should be able to just differentiate my power series, and this should be a representation of this function. So I don't differentiate the negative 1 to the n, that's a constant, but I do want to differentiate x to the 2n because that is a function of x, and that is the variable that I'm differentiating with respect to. X to the 2n derives to 2n x to the 2n minus 1. And also, don't forget that when I differentiate, I have to move my index forward 1. So this now becomes n equals 1, which is important because all of the answers I see are n equals 1. So this is where that n equals 1 comes from in this case. Whenever you differentiate, you always move forward. However, if you integrate, you don't move the index forward. You add a plus c to the end. Now, we have this, and we're really close. We need negative 2x squared over 1 plus x squared quantity squared. The only thing we're missing from this expression is an extra x term. So all I'm going to do is I'm going to multiply both sides by x. So I get negative 2x squared divided by 1 plus x squared quantity squared, and that's equal to n equals 1 to infinity, negative 1 to the n, 2n, x to the 2n minus 1, and if I multiply this side by an x, I end up with x to the 2n minus 1 plus 1, so therefore I get x to the 2n. Great. So now, I've found my power series, so looking at the answers given to me, I can assume that the answer will be A, which matches it perfectly.
The Teaching Center, UF's Learning Resource Center.